Okay, so today's lesson is a graphing lesson, and this kind of kicks off the last unit before we get into finals review. If you have an assignment that's due this by this Sunday, today's lesson is the first lesson that's covered on that assignment that I gave you already on Monday, or if you want to do Khan Academy, this is the first lesson that deals with that. Friday's class, what I have scheduled is these cards will be here, or I'll have at least one card here, so that if anybody wants to work on Khan Academy, or if you want to work on the assignment, you can actually work on it in class on Friday. And then if you look at next week's assignment, it's both really short and it's also only digital. It's only Khan Academy for next week, but it's super short. The purpose for that is I think I might still have it scheduled to give you like the full week until Sunday, but it shouldn't take you more than like a day because I want you to finish that as quickly as possible. And if I'm gonna try my best to have a review for you ready for the final by this weekend, so that I can give it to you next week. I can already start giving you the review, and you can start working on it, and have 2 weeks to work on it. Because you got 2 weeks left after this one, and then finals. Exciting. All right. So if you're gonna understand what we're gonna do today, let's compare it to what we already know. So. Before you got to me, you were introduced to function notation. So when you see something that says f of x equals, that's the same thing as saying what? Y equals, right? So if I were to write y equals mx plus b and ask you what that looks like on a graph, what would you say? You were with me. Just write a function with that general form. Now, I realize there's no numbers there, but you don't remember y equals mx plus b? You remember, Jair? Yeah. What was that a form for? Something like that, yeah. It's close. Slope-intercept form, yeah. Yeah, slope-intercept form of what, though? If I graph that, what does that look like? It looks like a straight line. Thank you very much. It looks like a line. And there was really three different forms of a line that we learned. We learned slope-intercept, we learned point-slope, and we learned standard. Okay, well, what we do now is, well, we keep that y equals, but now what we put on the other side is the standard form of a quadratic expression, of a quadratic polynomial, which you've seen before. This whole ax squared plus bx plus c, where a is the number out in front, b is the number in front of the x, and then c is the constant. And we're going to learn that, guess what? You can put that on a graph too. The way you put it on a graph is going to be different, but it can show up on a graph. The way it looks is going to be different as well. I was actually pleasantly surprised earlier today that about half of my second period seems to have been familiar with this. If so, I'm hoping you would also. If I were to ask you what this would look like on a graph, what would this look like? What does a quadratic function look like when you put it on a graph? Say it again. A parabola. And for those that are unfamiliar with a parabola, Marquise, what does a parabola more or less look like? It's like a U. It's like a U shape. Very good. So with lines, we learn three forms, three different arrangements of what you put on the other side of the y. For parabolas, we're going to learn two. I normally teach it the other way around. I normally teach what you're going to learn tomorrow first, which is called vertex form, and then standard form, but this is the way they had it on the calendar, so we'll stick to it this way. So when we graph the line, how many points do we need minimum in order to be able to draw a line? 2. And if you remember, though, when we graph lines, I always like to add a third. How would we graph lines? I always like graphing at least 3 points, so how would I find those points? What methods would we use to be able to come up with the points in order to connect those dots? And you want to give it a shot so we're not here waiting forever? No, you don't remember how to graph points? You don't remember which point we found first, and then how we would find the rest of the points after that? Yeah, normally we'd graph the y-intercept first, and then what would we use to find any remaining points? No, not really, no, there was a much quicker way with lines. Yeah, with lines. Yeah, we'd use the slope, right? We get 1 point and then we use slope to find the rest. Well, with parabolas, we can't, there's no slope. We can't use slope. Also, with parabolas, really the minimum you need in order to be able to graph a parabola is 3. You need to know the location of 3 points. I actually prefer doing 5. If this was an Algebra 2 class, I would force you guys to do 5, but I'm going to leave it at 3. The problem with 3 is that you're not going to have a lot of precision on your parabola. It's going to be a very rough sketch. Anywho, all right. So, arguably the most important point on a parabola, and because this is the one that has to be there, a parabola, just like a line, has an infinite amount of points. And technically on a line, you can draw any 2 of those points and you can still draw a line. But with a parabola, yeah, there's an infinite amount of points, but 1 point has to be there. And if you're going to graph, one of the points has to be what's called the vertex. And the vertex is where the parabola changes direction. You have upwards facing parabolas that change direction down here at the bottom. We'll learn a name for that. And we have downward facing parabolas that would have their change of direction or their vertex here on the top. Okay. See, normally I teach vertex form first, which is tomorrow. So that's where you would understand what this H and K means. But for today, let's just kind of, even though you don't understand why we're doing it, let's suspend disbelief and just take my word for it. And let's call the x of, because the vertex is a point, it has an x and a y. Let's call the x of the vertex H. And let's call the y of the vertex K. So the way that we find H is by using this formula here. Negative b over 2a. You saw something similar with the negative b part in quadratic formula. Negative b over 2a. Change the sign of the b and then divide by 2a. Where do you get those numbers from? From here. And then the way that you would find the k is, I believe maybe even what Marquise was saying, which is now to get this number, once you have a number, get that number and plug it back into the function. And I'm actually going to show you 2 ways of doing that. There's one way that I thought you've seen before, but let's see if maybe it helps some kids. What's going to help us graph a parabola is not a slope. We don't have a slope to help us. But what we can do to take advantage of to minimize the amount of work, I know that's something you guys like, is less work. Less work is better, right? Is to take advantage of the fact that parabolas have vertical symmetry. I could get any parabola and draw a vertical line right through the vertex, and each side will be a mirror image of the other side. I could get like any point and measure how far it is from that axis, and it would be the same amount of distance to get to the other side of the parabola. They're symmetrical with each other. So if you are asked for that axis of symmetry, it's called an axis of symmetry. What we learned, and hopefully you remember from when we did lines, any vertical line, the equation of any vertical line is going to start off with x equals, and then all I need to do is put a number. That number is going to come from here. It's whatever h is. It's the negative b over 2a. That is the equation of the axis of symmetry. That part should be real simple. The most amount of work that you're going to have today, if you consider taking steps and working things out to be considered work, is this whole thing of finding k. How do you? But it's not going to be too long. It only really becomes a pain in the butt if you have fractions. I doubt you'll be given them the last thing to be aware of is, okay, each form has its own benefit. To me, ideally, for graphing purposes, it's ideal to graph out of vertex form. Hence why in the past I've always taught vertex form first, because that's the better one for graphing. Because if you agree with the argument that I'm making that the vertex is the most important point, in vertex form, you're going to just be given the vertex. You don't have to do all this work to find it. It's just going to be given to you. You know, why did we like graphing out of slope-intercept form? Because they gave us the slope and they gave us the y-intercept. Whereas here you have to find it. But so even though in standard form you're not getting the vertex, they are going to give you another point for free. And that point is going to be the y-intercept. Where is the y-intercept going to always be located at? Located at C. So if you look up here, we can use A and B to find the vertex, but then we can use C to find the y-intercept. It's not as helpful as the vertex, but we'll take anything we can get. Whatever can help us do less work, right? That's what I always say. You know what? I found some better ones than this. I'm gonna skip this first page, and I'm gonna go ahead to try to help us out. Skip to this example here. It should be the fifth example. And they've already drawn a parabola for us. Before we leave today, we're going to graph a parabola ourselves, but here it's already been graphed for us. They just want to ask us some information. Okay, so let's start off with the first one. This is going to answer almost everything for us, but where is this vertex located at? Point. A vertex is a point. So a vertex is a change of direction. Later on, when I ask you about a change of direction, as a matter of fact, when you get to Algebra 2, then you start dealing with higher degree functions like third power, fourth power, and these functions start turning a lot. They actually call them turning points. You can actually call them turning points. So the parabola only has one turning point. What point is that? -2, -1. Fantastic. So this is going to actually answer a lot of questions for us. Okay. First off, this AOS, what do you think AOS stands for? Marquise, go ahead. The axis of symmetry, yeah. So the axis of symmetry is a vertical axis. If I were to draw it here, like for me, with the tool I have, the smartboard, I use like these broken lines. For you, I would just use like just draw lightly on your paper. But an axis of symmetry goes vertically right through the vertex. And then what should happen is that on each side of that axis of symmetry, the parabola should be a mirror image of the other side. Should just look like looking in a mirror, like it's twin. And since vertical lines always start with x equals, the axis of symmetry would be x equals, but then I need a number. What number did I tell you is always going to go on the other side? No. What number is always going to go on the other side? The x of the vertex, which, even though you don't realize why yet, what are we going to call the x of the vertex? What are we going to end up referring to it as starting tomorrow? H, yeah. So in this case, it's -2, so let's write -2. The domain of a parabola is real simple. It's always going to be the same thing. What does domain mean? What are all the x values? How far left does the parabola go? How far right does the parabola go? And even though by the arrows it looks like the parabola is going straight down, a parabola never goes straight down. A parabola will always open out to the left and it'll always open out to the right, and it'll always do so forever. If I give this enough space, it will go forever left and forever right. So depending on how they're asking you, you can say that the domain is either all real numbers, this is the symbol for real numbers, or more than likely, they might ask you for this in interval notation, which is one of the things you learned before you got to me. And in interval notation, this is written as negative infinity to positive infinity. Those are two different ways of writing the same thing. The range comes from the vertex. See, because a parabola will always go forever left and forever right, but it does not go forever up and forever down because it has a turning point. In this case, the turning point is called an up to down turning point, because if you think about this as like a roller coaster ride, here's Colin, he's riding the roller coaster. He's like, going up, he's 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 going up. He hits the vertex, whee! And he comes back down. That would be Colin, right? No, he's a thrill seeker. So, because a parabola does not go, it only goes forever in one direction. You can explain the range using an inequality. In this case, if it's going forever down, it's gonna be less than or equal to some number. And when we're talking about range, we're talking about y. So y is gonna be less than or equal to some number. Take a wild guess what that number is gonna be. Yeah, which can be found also from the vertex. What did we say we're going to call the y of the vertex? Okay, yeah, we're going to call it case okay, y less than or equal to negative 1. That's one way of writing it. If you were to write this in interval notation, okay, because you have to go from smallest to biggest, what's the smallest y that's part of this graph? No, what's the smallest y? Not what? Oh no, that's what the picture shows, but the arrows, negative infinity. This goes all the way to negative infinity, to the darkest depths of the earth. Comma, how high does it go? -1, but since it actually touches negative, see, you can't touch infinity, that's why it has parentheses, but since it actually touches -1, you gotta put a bracket. You don't like brackets, Colin? Those are the boringest symbols on earth. Studies have shown. Does this parabola open up or down? No. It does open down. I almost had a heart attack this morning. Can you believe that I actually said something that was not on the board? I actually just said it like it came out in words. Somebody wrote it down on the paper. I was just flabbergasted, like without me having to say, write this down, write this down, write this down. Somebody just wrote it down. So we'll see. Almost, yeah. I was just shocked. I can't remember the last time I've ever actually seen that. I thought you were serious. No, I'm not. I'm serious. So anyways, just so that you know how that relates back to this stuff, even if I couldn't see a picture of a graph, I could tell you if it's going to open up or down based on A. If A is positive, parabola opens up. If A is negative, parabola opens down. See, so like we're fortunate enough to be able to see the parabola on the problem that we were just doing. But if you can't see the parabola, but you can see the equation, A positive, up. A negative, opens down. Back to here. When your parabola opens down, these words of minimum or maximum, those are referring to the vertex. So when you have a downward facing parabola, is your vertex at the top or at the bottom? It's at the top, so yeah, it would be called a maximum, or you can just call it a max. That's his nickname, Max. Does he know you? You know that max spelled backwards is Zam? Zam. And then finally the y-intercept, where is this touching the y-axis? Where is it touching the y-axis? At -9. 0, -9. And coincidentally, that we've actually already learned. If I was looking at the equation, where could I expect to see that -9? Because I'm about to do some now where we give us the equation. Where do you find the y-intercept when you're given the equation? Oh, okay, well, fine. The constant, but fine. What else do we call a constant? Yeah, most people will call it C. I think if I say constant, half of you don't know what I'm talking about. But if I say C, hopefully you know what we're talking about. You also have a friend named C, that they call him C for short. And then if he's like really short, they call him Lil C. But then if he's like big and strong, they call him Yo Big C. What up though? Like that. See, I told you. All right, well, let's do one more like this. Let's see if we can get to this one quicker. Where is the vertex located here? Yeah, but give me an actual, like, I need an actual location of it. This is going to be a 1, -4. Thank you, Colin. Even if they wouldn't show me a diagram, if they didn't show me the graph, as long as I know where that vertex is located, you can give me the equation for the axis of symmetry. Okay, it's always going to be x equals, and then because it's vertical, and then yes, you're right, it would be whatever the x of the vertex is, also known as h. Sorry, that's a 1. My hand slipped. The easiest question you'll have today, what is the domain? Yeah, the domain of every parabola is going to be all real numbers. So I'll just start to save space. I'm just going to write this in interval notation. I just have a feeling you're more likely to see it this way on the test. So that just means all real numbers. Negative infinity to positive infinity and everything in between. How about the range, or El Rango, as some people say? Well, see now, yes, all these red points are above the vertex, so it's going to be y greater than or equal to, not less than or equal to, because all the points are above the vertex. And how low does the parabola go? Negative what? Negative 4. Does the parabola open up or down? This one's going up, therefore is the vertex a max or a min? It's a min, it's at the bottom of the map. And then Kiara, where's the y-intercept at? Brandon, do you agree? It's good when Brandon agrees. It's better when Brandon agrees. So now let's see if we can come up with our own graphs. Instead of them giving us the graph, let's go backwards to the second example, and let's start graphing ourselves. Notice how we're being asked the same questions though. And I actually liked how this worked. Because I did this in second period, I actually like the way it works, so I'm going to try this again. Let's see how many of these we can answer without even touching the graph. Can I answer the vertex? Yeah, but I have to find it. It's going to require some steps. And without the vertex, I'm going to struggle with the other. I need the vertex for axis of symmetry. How about domain? Can I answer domain?
Oh, yeah.
Of course you can, because what's the domain of every parabola that's a function? All real numbers. So I know the domain's going to be all real numbers. So negative infinity, negative infinity, positive infinity. Can I find the range? No, I need a vertex for that too. I mean, I'll be able to find it. I'm talking about like, what can I find just by looking at this? Can I tell just by looking at it if it's going to open up or down? How do you know it's going to go up? A is positive, yeah. So, and actually, you know what? Let's do that first. Let's identify A, B, and C. What's A here? What's B? And what's C? Okay. So yes, you are absolutely correct. Because A is positive, it's going to open up. And if it's opening up, what? I'm not asking you where the vertex is, but what type of vertex should we have? Is it going to be a max or a min? It'd be a min, yeah, because if we're going up, that means Colin is going to be at the bottom of the roller coaster. He's going to be going down first and then back up. That's to be a min. And where's the y-intercept going to be? At 0, -4. Because how can you tell that, Colin? How can I tell where the y-intercept is going to be? So you can tell all your friends. How can you tell me where the y-intercept is? Georgiana? That doesn't have to do with the minimum. The y-intercept is always going to be at C. So far, I know that I can already even put a point. How many points? Because now I'm going to have to graph myself. What's the minimum amount of points? What's the minimum amount of points I need in order to graph a parabola? Yeah, 3. It's with only 3 points. It's a pretty good chance it's gonna look like a pretty crappy parabola, but whatever, we'll do the best we can. So, then I put a point at 0, -4 on y-intercept. But I'm missing quite possibly the most important point, which is the vertex. So let's find it. In order to find the vertex, okay, you don't understand it yet. You will tomorrow, hopefully. But let's call the vertex h, k, where h is just a specific name of the x of the vertex, and k is just a specific name for the y. So let's find h first. That one shouldn't be too much of a challenge. What's the formula I gave you for finding h? Negative b over 2a. If b is 2, what is negative b? Negative 2 over 2 times a, which is 1. 2 over negative 2 over 2 is going to be negative 1. Bam. Let's go back over here. Not that I really recommend for you to be jumping back and forth, but this is just kind of like a little exercise to see how well you're understanding the connection between these two things. Jada, you having a bad day today? So for the vertex, I know that the x is going to be -1. What else can I answer? The axis of symmetry. Where's my axis of symmetry going to be? I love it when Colin's having a good day. I'm fire today. But now, how do we find the k? Sadly, this is going to be the most mathy thing today, where you're going to have to get this -1 and plug it in for all of the x's. Since the h is a type of an x, we're going to plug it in for all the x's. So we're going to say that this function, and actually whatever, let's just call it k, so as not to confuse anybody. So k is going to be equal to, instead of x squared, -1 squared, plus 2, instead of x, times -1, and then -4. What's -1 squared? +1, good. 2 times -1 is -2, -4. So my k is -5. I can now answer the second part here. This is -5. And then I can also answer the range. Because that -5 is going to be a minimum, that's how low the graph is going to go, what would the range be? You could say greater than or equal to -5, or you could say See, if it's going up, yeah, so it'll be -5 first and then up to positive infinity. Or you can just say y greater than or equal to -5. But look, I have more for you now. A little bonus. Go home and say mommy and daddy, look what I learned in school today. Because this is not something I'm really even supposed to show you yet, but what I don't want to do is confuse you. Okay? Has anybody here ever seen Men in Black before? You ever seen the movie Men in Black, right? Where they have the little light thing? Yeah, with Will Smith, and then and then it flashes the light, and then they forget everything. Okay, so if you don't like what I'm about to show you, just pretend like I'm flashing the light and forget about it, because you don't need to know this. But this is just something that maybe if you like it, maybe you're less likely to make a mistake. What would you say has been the hardest thing? Even though I don't think it's been hard, but what has required the most work today? The finding of k. So there's a little bit of a trick that can be used. So there's a process called synthetic substitution, which I doubt you've learned before, but that it can be used to evaluate a function if it's a polynomial function like this. So here's a little trick. What was the number that I plugged in? -1. So get that -1 and put it like in a little balcony. And after you write that -1 in the balcony, then write A, B, and C right next to it. So 1, 2, and -4. And we're going to leave a little bit of space, and we're going to draw the ground. Okay. Now, I realize that people don't really go below ground and above ground, but let's just suspend disbelief. And let's pretend that this -1 here was like Rapunzel, and it's like letting its hair down, and it wants to bring numbers up, but then numbers want to go down, and numbers want to go up, and numbers want to go down, right? So every time you're going to go up, every time Rapunzel is going to bring you above the line, it's going to be through multiplication. Okay, multiplication brings you above the line. Addition brings you below. You start off with the first number that's not on the balcony. Nobody's there to protect it, so it falls down. It falls down to the ground. And it's actually going to go below ground. Start off with the first number and just drop it below the line. Yeah, well, because remember, I told you, in order to get down, what are you doing? You're adding, right? Well, what's below the 1? Nothing. What's 1 plus 0? Well, it's 1. That's why it's just kind of like it drops. Now, to get back above the line, what are we going to do? Multiply. But Rapunzel is the one that's always helping us get back above the line. So we're going to always multiply with Rapunzel. What's -1 times 1? By the way, this is my little prediction. My answer is going to end up there. How do you get back below the line? Add 2 and -1 is 1. How do you get above the line? Multiply, but always multiply with Rapunzel. And then when you add, what did k end up being? If you don't like it, throw it away. Don't use it. Just do it this other way. But surprisingly, I even had some people in second period like, oh, can you do this next one with that way? So it's up to you. If nobody wants me to do this again, erase it from your mind. I won't do it again. I will just do what's in blue. But if you want me to do it again the other way, I can show you that it always works. Sorry, I have to graph. So the vertex was going to be at -1, -5. So -1, -5, that's right here. Now be careful that you don't get confused with this, okay? The axis of symmetry, we're going to draw it really light on our paper, but make sure that you always remember that the axis of symmetry goes through the vertex, not the y-intercept. Unless for some instance, it is possible that the y-intercept could be the vertex, but it's rare. Are you dabbing, Colin? It's like 4 years ago, man. How many points do I have in the graph so far? 2. How many points did I say I wanted minimum? 3. So the way, now we're going to use this axis of symmetry to find the last point. How far away was this y-intercept from the axis? One little box, 1 unit. So just count 1 unit on the other side. Flip the script. Now I have so the points that are symmetrical, and I'll just connect the dots, just trying to make it look like a U kind of a thing. It's going to be an ugly sketch because we don't really have that many points. And just what I really don't want, I know of teachers that do not give credit for this. I've seen this before where teachers will mark this wrong. And I try to kind of I'm on the fence about it. But what you don't want to do, and this is another reason why I don't like just 3 points, do not connect these with a straight edge. Do not use a ruler and just draw straight lines, because a parabola, that's actually an absolute value function, looks like that, not a quadratic. So just try your best to just try to make it draw and make it look like a U. Try to make it look U-y. Of going through those points. Aight. Okay, let's approach this one the same way we did the last one. But let's identify A, B, and C first, and then let's see how many of these we can answer without even looking at the graph. What's A going to be here, Jada? Good. -1 will work. Brandon, what's B? 2. Jair, what's C? You're the man, Jair. And let's see how many of these questions we can answer. Can we already tell what the vertex is going to be? No, not with a little bit of work. Can we tell what the axis of symmetry is going to be? Now without the vertex. Can we tell what the domain is going to be? What, Nakai? You can say all real numbers, or you can say negative infinity or positive infinity. Parentheses. Can we tell what the range is going to be? Now without the vertex. You need the vertex for the range. Because remember, you're going to turn around. You don't know where you're turning around at. Can we tell if this opens up or down? Hey, how do you know it's going to go down? Okay. And if it's going down, even though we don't know where the vertex is yet, is that vertex going to be at the top, a maximum, or at the bottom? It's going to be at the top. It's going to be a max. And Jair knows someone named Max, so it's kind of like a perfect pairing. Kiara, how dare you? Can I tell where the y-intercept is going to be at? Where, Sam, where? Where's the y-intercept? At 0, 3. Now, everything else we need the vertex for. If you want to go ahead and plot the y-intercept, go right ahead. You have my blessing. But now let's find the rest. For the vertex, first let's find h. What's the formula for finding h? Negative b over 2a. If b is 2, then we have negative 2 over 2 times negative 1. So that's going to be negative 2 over negative 2, which is positive 1. Georgiana, that's confusion face. 2 times negative 1 is negative 2, so what's any number divided by itself? So it's 1. So I now know that for my vertex, the x is 1. I know that my axis of symmetry is going to be at x equals 1. But I need to know the y. And once I know the y, I know the range. In order to find the y, I'm going to get that original function, and I'm going to plug in a 1 for every x I see, but be careful with the signs. That first negative stays away from the 1. I'm not plugging in a negative 1, I'm plugging in a 1. And that's going to be important with signs. When you square a number, what type of sign should you always get? Positive. But what happens here is people don't realize what they're squaring. I'm not squaring a negative 1. I'm only squaring a 1. So yes, I agree with you. 1 squared is positive 1. But that negative is just waiting on the outside to count. And once I square the 1, it's going to take over and make it negative. 2 times negative 1 is minus 2, and then plus. Did I write something wrong? I feel like I wrote something wrong. Oh yeah, I did. Yeah, I wrote a negative 1 here. Sorry. It should be a 1. So plus 2 plus 3. Negative 1 plus 2 plus 3. 12. So now I know that the vertex is going to be at 1, 4. And even though I can't see a graph, since that vertex is a max, is at the tippy top, what's the range going to be? If the max is the highest it goes and every other point is low, y less than or equal to 4, or you can say it in just so that you can see the difference in interval notation. Since the lowest it's going is negative infinity, that has to come first, and then you would write 4 but with a bracket. Now I can. Oh, I'm sorry. Does anybody want to see me do the synthetic substitution again? You want to see it, Brandon? Okay. So if you want to use that shortcut for plugging in, what's Rapunzel going to be here? What am I plugging in? No, what did I plug in? Oh, 1. So I put that first. Then I just write ABC. Negative 1, 2, and 3. My K is going to end up going here at the end. Let's see what number ends up there. Column, the first number drops as if it was hot. How do you get above to the line? No. Above the line is multiply. Always multiply with the balcony. 1 times negative 1 is negative 1. Put it at the top of the, above the line, but on the next column. You're moving over to the right. 2 and negative 1 is 1. Multiply again, you get 1. And when you look at that, we ended up with same thing. So when we graph 1, 4, remember that the axis of symmetry goes over the vertex. How far away is the y-intercept from that axis? 1. So you go 1 on the other side, and then all the children have their downward facing parabola. Hang in there, Nakai. Let's do one more. Last one. Georgiana, what's A, B, and C? Good. Shiobi, do we know where the vertex is going to be already? No. Do we know where the axis of symmetry is going to be already? No. Do we know what the domain is going to be already? What's the domain? Good. All real numbers, negative, infinity, to positive. Good. Do we know what the range is going to be? No, we need the vertex for the range. Do we know if it's going to open up or down? Where's it going to go, Shiobi? Good. If a parabola opens up, is the vertex at the top or at the bottom? At the bottom, so that's going to have a minimum value. And where's the y-intercept going to be? At 0, 1. Go ahead and put that point there already if you want. But I need 2 more points. I'll get 1 more point from the vertex because I have to have the vertex. I'll get the last point from flipping the script on the axis of symmetry. What's the formula for H? Formula for H. Negative b over 2a. So change the sign of the b to negative 4 over 2 times 2. So this happens to be the negative 4 over 4 is negative 1. Then I would get that negative 1 and substitute it to find k. So 2 times negative 1 squared plus 4 times negative 1 plus 1. So k is going to be negative 1 squared is positive 1. So 2 minus 4 plus 1 is negative 1. Did I do the same thing? No, I didn't. If you wanted to see me do it the other way, if not, then you can just ignore this, but I plugged in a negative 1, and I plugged it into 2, 4, 1. So now the 2 is what dropped. There's a way, man. Negative 2, 2 multiply negative 2, and yep, I ended up with negative 2. So my vertex is going to be at negative 1, negative 1. What's going to be the equation of my axis of symmetry? X equals negative 1, and then the chi, what's my range going to be? Well, you know that range is going to be with a y. And if this vertex is at the bottom and everything is going up, it's going to be, you can say y greater than or equal to this negative 1. Or, if you want to do it in interval notation, since everything is going up, first you want to put the low point. So the low point would be the negative 1. It needs a bracket because it's touching it. And then up to positive infinity. I would now put my point at negative 1, negative 1. Remember, because look, even sometimes if I'm not concentrating, I make stupid mistakes too. Remember to draw your axis of symmetry through the vertex, not through the other point. How far away is the y-intercept? Yeah, 1 unit, so just go 1 unit on the other side. Of course, then people ask me, but mister, is it always going to be 1 unit away? Not necessarily, but yeah, it's very common. It all depends on what points you use. Any questions there? You've been a wonderful audience. Tomorrow we'll do vertex form.